This question is quite long. It's a question that tests you on R formula, but it added in some double angle and also differentiation. The differentiation component will be the maximum minimum. So for the first part, you are given a diagram and your job is to investigate the parameter. Okay, so the parameter, if you look carefully, is there. You already given the slant side and the vertical side. So the problematic part will be these two. So what you do need to do is you need to cut something. You need to cut something to form a 90-degree right angle triangle so that you can do some trigo. So whenever you see a trapezium like this, you should cut it in this way. So you should cut it in this way so you can see that there's a right angle triangle. Okay, so to make things easier, I'm going to do it this way here. I'm going to draw it out. So I added in the dotted line. And after I added in the dotted line, I'm focusing on this triangle. I also added in a new point so that it's easier for me to reference. So I mentioned about P. Okay, and then this is the triangle that I'm focusing on. So based on this triangle, I can do a sine theta or I can do a cosine theta. So if I do a sine theta, I will be getting O over H. So my O is PM. And that's how I gotten PM. So PM will be equivalent to this part as well. So if I do a sine O over H, I will get a PM. And similarly, if I do a A over H, I will get a PN here. So I just simply use a triangle. I do a normal trigo. I can get these two expressions. So if I can get this part as a 12 cosine theta, the whole thing that I will need, I just add in an extra 5. So I add up all the length, and that will be the expression that is given. So it's not a lot of marks because it's actually quite easy. The main mark is awarded here on the trigo triangle. Then subsequently, if let's say you couldn't prove, you take the expression. You take the expression and you continue. So you isolate this part to be converted to a R formula. So if you need to know how to convert to a R formula, you let me know. Okay. The formula will not be shown in O level. So you need to remember the formula. How do you convert it to R formula? Okay, so I will not be explaining, but if you need this part, you let me know. You just need to apply formula. So I apply 2 sets of formula to get the 2 values. And once I gotten this right, the question asked me to state the maximum parameter. So first of all, this one is part of the parameter. So because of this, my parameter will become 22 plus 12 root 2 cosine theta minus 5/4. So how do I get the maximum parameter? So remember the function, the cosine function. The cosine function will be the highest at value 1. So my parameter will be when cosine will be, the cosine function has a value 1, and that's how I got the maximum parameter. So in a way, the parameter is very much limited by the cosine function. So if the cosine function doesn't go any higher, then the parameter cannot go any higher. So that's how I gotten the maximum parameter. And the maximum parameter happen when the cosine function is equal to 1. Okay, so the question only asks for the maximum parameter, so I will not need to find the corresponding value of theta. So if they do, then you need to continue with basic angle ASTC in order to find what is the theta that corresponds to this maximum parameter. The second part, the third part is another proving that deals with the area of the trapezium. So the plate is in the shape of a trapezium. So you got to review the shape. So if it's a shape of a trapezium, these two will be the parallel line, and this one will be the height. So by now, you already have gotten all the sides. So you just have to identify the correct parallel line and the height. So this will be the height, and this part will be the A plus B. So you just need to identify. You already gotten the length that you need in the first part, unless you couldn't prove the first part. If you couldn't prove the first part, you wouldn't have all these that you will need in the third part. Okay, then if you do out your area of the trapezium, you will find this part. You must be able to relate to a double angle formula. The double angle formula is provided in your O-level list. So you got to look back at the double angle and condense this double angle. So if you condense the double angle, then it will be something like this. That's how we get the 36 sine 2 theta. Okay, so this is the part that involves a little bit of double angle. And then we got to apply our idea of stationary value. So in the next part, the maximum area is obtained when it gives a stationary value. So this is the stationary point concept. So I got to differentiate. You got to remember the concept. Stationary area means I got to differentiate area equal to 0. So that's exactly what I will need to differentiate. So I use the expression, even if I can't prove it, I will just differentiate the expression and I will set the expression equal to 0. Now, when you set the expression equal to 0, it becomes a trigo equation. Because your expression, your differentiation is in trigo. So when you set it equal to 0, it becomes a trigo equation. And your trigo equation involves double angle, and you will need to change it out. Refer to the list. You got to change it out, and eventually you must see that you get a quadratic equation. So for some of you, if you find that it's easier if you use substitution, then you go ahead and do your substitution so that you can see the quadratic equation easily. And this quadratic equation is not something that is factorizable. So some of you may get insecure. So you might feel that, did I do something wrong? Okay, so if you work out your quadratic equation, you will have gotten 2 answers. Okay, there you can work out the 2 answers. One of the answers is that means, right, if you work out these two, the plus minus, you will get one of them as positive and you will get another one of them as negative. So in the context of this question, the theta that I'm looking at couldn't be an obtuse angle. It has to be an acute angle. Otherwise, the shape will not form out this way. So you need to understand that it's an acute angle. That's why I will take the positive value and then I will just find the answer based on the first quadrant. And that is the value that gives the stationary value of A. So in case some of you are wondering, so do I need to prove that it's a maximum? If you can try to prove that it's a maximum. To play safe, yes, you can. But if let's say time is running out, you realize that they only ask you to find the value of theta, then you can just skip that. But of course, if you can afford the time, please go and prove that it's a maximum. So how are you going to prove that it's a maximum? You can do the second derivative. That means you got to differentiate one more time, then punch calculator. Or you can do the first derivative. It's up to you. Okay, so this one is a pretty long question. Rformula proving, there are 2 sets of proving, and one of them involves double angle. And it also have a stationary differentiation concept.